In this lesson, we are going to learn how to name ionic compounds. The fundamentals. The first thing is that we will always write the cation is always written first in the name, and the anion is always written last. So the cation, when we are naming it from the chemical formula, there is no change to the name of the metal cation. So if the metal is if I were showing you NaCl, the cation, this is sodium, and you do not change the name of that metal at all. It's just still sodium. Teacher's tip, ask yourself if this cation needs a Roman numeral. Common elements that do this are vanadium, which is V, chromium, which is Cr, manganese, Mn, iron, Fe, cobalt, Co, nickel, Ni, and copper, Cu. Those are all in the first row of the transition metals, but there's a couple other metals that do this that you're going to see frequently, and that's tin and lead. They are a little bit outside of the transition metals, but these are common ones that you will be tasked with writing their names and want to make sure you recognize those. All right, so these are transition metals. We'll consider all of these to be transition metals that have more than one possible charge. So what I'm referring to, if you look here, these have more than one possible charge listed, and we may have learned when we're using nonmetals, we always take the top charge, but metals are different. If there's more than one possible charge, we have to indicate what charge it is, and we are going to use a Roman numeral. So these will need a Roman numeral in the name. So if you want to indicate that the charge on the ion is a +1, you will use Roman numeral 1. If you want to indicate that the charge is a +2, you will use Roman numeral 2, etc., and so on and so forth. So there's your little cheat sheet for what the Roman numerals are. For the anion, and of course this is not an example of the sodium chloride that I gave you up here, but we'll see this in a moment. The anion. If the anion is what we call a monatomic ion, meaning it contains only one element, we're going to change the ending of the element name to have the IDE ending. If the anion is a polyatomic ion, meaning it consists of more than one element, we're going to use reference table E to determine its name. Reference table A looks like this, and it can be found in the reference tables looking on the page with reference table E and reference table F. Okay, but this is what it looks like. And what you would do is look up the formula of the ionic of that polyatomic ion, and then the name is just given to you. So these are all names of anions, with the exception of these three right here are the only cations that are on this. Every other ion on this chart are anions. So example, what is the name of CaCl2? Start by naming the cation, right? So you need to know that Ca is a metal that is called calcium. If you're not sure of this, you can go to reference table S, find the symbol Ca, and you will find its name there. That name is not going to change. The next question you ask about that metal is, does it have more than one possible charge? And when we look up calcium, it does not. So that means it does not need a Roman numeral. Now, next we look at the anion. Here we have chlorine, and what we do there is chlorine. There's only one type of element there, so we are going to change the ending of, instead of being chlorine, we're going to take off that INE, and it's going to become chloride. Okay, so that's how you work that kind of example. All right, let's take a look at this example. What is the name of CuCl2? The name of the first element in here is copper. Copper is one of the elements that can have more than one charge. It can either be a +1 or a +2. We need to figure out which one it is. To do that, well, we'll come back to that in just a second. So we are going to need a Roman numeral. I'm going to leave parentheses there and a blank space, and I'm going to put a Roman numeral there momentarily. It's either going to be a 1 or a 2 because those are the only two positive charges copper can be. We know this Cl is going to be chloride. It's just it's a monoatomic ion, meaning there's only one element there, and I know there's 2 there, but here's what's going on. We know to figure out the charge on this copper right here, we know that chloride's charge is a -1. So we have to figure out here that if we needed 2 of these chlorines, right, what that means is this. We needed 2 of those chlorines. That must mean that this copper had to be, because there's only 1 of them, it had to be a +2 charge. So here you're kind of uncrisscrossing. You're doing the opposite of the drop and swap to figure out that this is a Roman numeral 2 to indicate that the copper has a +2 charge. The next example is very similar. We have copper and we have chloride again. And we know that copper is going to need a Roman numeral. In this case, there is only 1 chlorine. So we know that that chlorine ion is a -1. And since there's 1 of each, there's 1 copper, 1 chlorine, this copper had to be a +1, so that is a copper 1 chloride. And so that's how we can name these 2 substances differently, dependent on the charge on the cation. Example, what's the name of MgOH2? Mg is an element called magnesium, except I can't spell, magnesium. It does not require a Roman numeral. There is only 1 possible charge. And then we've got this OH business, which we have to go, that is not a monoatomic ion, so we are going to find that ion on reference table E, and we find it right here, OH. OH is a -1 charge. That's why there's 2 of them, because magnesium's a +2. That's why we had this 2 in the first place. But that doesn't matter for the name. This OH is called hydroxide. And remember, we do not need a Roman numeral here because magnesium, we figured out that it's a +2 charge, but that's the only charge that magnesium can be. So we do not need a Roman numeral. So this is just magnesium hydroxide. The last example here, NH4,2SO4. There's a lot going on here, and what you have to learn to recognize is NH4 is a polyatomic ion that we're going to find in reference table E, and SO4 is going to be a polyatomic ion that you find on reference table E. So if we look up, if we see NH4, that's a polyatomic ion called ammonium. So the first part of this is ammonium. SO4, not SO3, careful, this is SO4, that is called sulfate. So in some ways this is simpler because the names are just sort of spelled out for you on reference table E. The tricky part is becoming familiar enough with the ions that are on reference table E. So that is something that you'll want to spend some time kind of looking that over to become familiar with those, and so you can recognize them easily when naming compounds. So in this lesson, we learned how to name ionic compounds given the chemical formula. We took into consideration whether or not the cation needs a Roman numeral. We also took into consideration whether or not we needed to look at reference table E to name polyatomic ions. That's it for now. We'll see you back in the classroom.